All right, you guys, I'm going to start off with question 43. And 43 is asking you to just put these algebra tiles to get them out. So I got 7 of the x's and 1 of the x squareds and 6 of the 1's and turn it into a rectangle. So the way I did that, and I think it wants this x squared in a corner. So we'll make that a corner. The way I did that was this way. Let's see. And remember, the x has to go next to the x side. You can't stack up the 1's to make the x because they're just not the same size. And then if we put 6 of these x's in a row here like this, this is how I built whoops, my rectangle here. Okay, and that's question A, I think, but let's go back and read it and make sure that we have everything correctly. Okay, so there is my rectangle, and I'm gonna just snap a picture of this so that I can write on it for you guys. Oops, copy. So here is our rectangle, and that's part A of the book. Okay, is to arrange the tiles into a large rectangle. Sketch what that looks like, and it's kind of what I just did, even though I cut and copied. And B says the area of a rectangle can be written as the sum of all of its parts. Write the area as the sum of all of its parts. So what that means is here that we have 1 of the x squareds, right? We have 1 of the x squared, so we're just going to count that as 1. So we have 1 x squared plus, so we're adding it all together. And then we are going to say we have how many of just the x? So we have 1, 2, 3, 4, 5, 6, 7. So we have 7 x's, so we're going to add 7 x's plus, and then there's just 6 of those 1's, right? Let's see. 1, 2, 3, 4, 5, 6. So we're going to add 6 of those 1's. So that's the area. This is what the area looks like when we add up all of the parts on the inside. Okay. Now, question C says the area of a rectangle can also be written as length times width. What are the dimensions of the overall rectangle that you made? Label your sketch with dimensions, then write the area of the rectangle as a product. That is length times width. So we also know that the area of a rectangle is equal to the length times the width because that question told us, and because I think you guys should know this. Cool, so we need to find, generally we recognize the longer side of a shape as the length. So we need to figure out what the length of this shape is. Let's do that with green. So from here to here is x, and then from here to here is 6 1's. So the length is equal to x plus those 6 1's. And the width is equal to, we have 1 here, and then we have x. So the width is equal to x plus 1. Okay, so, and I had that in parentheses, I'll put them both in parentheses. So when we rewrite the area as the length times width, we're going to rewrite it as the area is equal to the length, which is x plus 6. Did I say the length plus 6? I meant 8 length times width, duh, times x plus 1. So now I have the area written in 2 different ways. So I think what's next, it says, and this is important because this is what the question on the test is going to ask you. Write an equation that shows the area written as a sum is equivalent to the area written as a product. So it literally just wants us, to write our first area, x squared. I don't actually need that one, so I'm just going to put x squared plus 7x plus 6 is equal to And then how we did the length plus width is equal to x plus 6 times x plus 1, okay? That's the answer it wants for D. All right, so what's next? What's next is 44, and 44 says, for each expression below, and they're expressions because there's not an equal sign or else they'd be equations, build a rectangle using all of the tiles if possible. Sketch that rectangle and label its dimensions. Write an equation that shows, okay, label its dimensions, that's the length times the width. Write an equation that shows that the area written as a sum is equivalent, right, because of all those addition signs, is equivalent, that was cool, to the area written as a product. Oh, it didn't do it. Oh, it did do it, that's fine, cool. If it's not possible to build a rectangle, explain why not. So let's take a look at A. A says that we have 1x squared, 8 x's, and 12 ones. So let's see. Oh, what was I trying to do? 8x squared, 8x, and 12. Okay, so we have my x squared, but this time we have 8 x's and 12 ones. So I had 8, 9, 10, whoops, 11, 12. So how am I going to make this work? So now I have 8 x's and 12 ones. So I think, let's see. Oh wait, I don't have 12 ones yet. I only have 10, 11, 12. And now I can put them, I think, this way. Yeah. There we go. Perfect. And actually, let me see. I think I can do this, you guys. I think I can write on the actual thing. So now my width is 1x and 2 ones. And when I'm talking about the length and the width, I'm not talking about the area. The area is written on the inside. So the area of this block or this tile is also x, but it's x because this is 1, this side is 1, and this side is x. And when we multiply those two together, we get x. X times 1 is x. So the width is x plus 2, and that means both sides are x plus 2, right? X and then 2. And the length is an x here, and then 6 ones. So 1, 2, 3, 4, 5, 6. So 6. Like the length is x plus 6. So when we write the area, we want to rewrite the area as a sum, which was x squared plus 8 x's plus 12 ones is equal to, this is what it's talking about, is equal to the length, x plus 6, times the width, x plus 2. And this is going to come in so handy when we start talking about factoring, which is what we're leading into. Sorry guys, my mind went blank there for a second. So actually, where I am now, I want you to write this down. If you can go to this website, technology.cpm.org/general/tiles, you will have access to these tiles and you can finish up question 44, just like this one. This is the tile. Let's see if I can get rid of this. This is the tile XY, which means one side is Y and one side is X. It looks like it goes right there, but it's actually doesn't. It goes with the Y. Okay, so if we put these, check this out. If I put this Y next to the X, the Y should be bigger. It's just a little bit bigger here. I'm gonna make it a lot bigger because that's how it looks on our regular tiles. It's not equal to X. And then this one side is gonna be equal to that Y, and one side is gonna be equal to that Y, and one side is going to be equal to that x. Okay, I wish it had it written out a little bit differently on there. But you should be able to finish up 44. Let's go back to the questions and see what's after 44. Okay, so 45 is using this question at the right. And it wants us to do the same thing. Add up all the insides of one. We have, let's see here. 1, 2, 3, 4, 5, 6x squareds. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 x's. And then how many? 1, 2, 3, 4, 5, 6 ones. And then you need to figure out the length. So the length there is x and x. So that's 2x plus, and then 1, 2, 3, 3 ones. So this is the length. I'll let you guys finish it by figuring out the, whoops, I guess that would be the width because it's shorter, by figuring out how long the length is and writing that answer correctly, hopefully correctly. All right, 46. You may recall using a rectangular area model like the one below in previous math courses. So what this means is that, let's see, I thought this had a highlighter here, but that's okay. We'll just work with this. The reason this is 4x is because this side is 2 and this side is 2x. Since it's a rectangle, this 2x is also up here. So 2x times x is 4x. If it's a 3 down here, it's also a 3 here. That's why the 2 times the 3 is 6 here. 3x times 2x, 3 times 2 is 6, and the x times the x create this x squared. 3 times 3 is 9, and then there's only one x, and then 3 times 2 is just 6, okay? And it just kind of wants you to talk about how it's the same as what we did and how it's different. And then 47, area model puzzles. What it wants you to do here is to talk about, oh, how do I erase this? Oh, there we go. Is to fill in the puzzle. If I know this side is x right here, then I also know that it's x above, right? And then if it's 3x squared, what did I multiply this x by to get 3x squared? Well, I had to multiply it by 3 and then also by an x because there's 2 x's, right? Or it's x squared. X times x is x squared, and 3 times 1 is 3. And then if that side's 3x, because it's a rectangle, I know this side's 3x. And 3x times what is 6x, and that's going to be just 2. Okay, so what it wants us to write then is 3x squared plus 6x, that's the inside, is equal to my length times my width, is equal to 3x times x plus 2. And that's the answer it wants. This is the sum. This is the product. Okay, so this one down here, that means if this side is x, that means this side's also x. This is 1. X times what is x? That's just 1. If that's 1, that's 1. If these are both 1, then the inside is 1. 1 times 1 is 1. And then how do we get this x squared? We know that this is x. It would be x times x. And if this is x, and x times 1 is just x. So now the inside is we have 1x squared, we have 2 x's, and then we have 1 is equal to, and the sides, x plus 1, both sides, oops, both sides are x plus 1. Okay. C, oops, sorry. See, I made this little mark here, and I want you to realize it's plus 1, not minus 1 there. If this is 2 and this is negative 4x, this must be negative 2x. If this is 3y, this is 3y up here. That means this must be x, because we needed to get that x in there somehow. Let's see, if this is 2, this side's 2. If this is negative 10, this must be negative 5. That means this is negative 5x. if this is x and this is negative 2x, this is negative 2x squared. And if this is 3y, then this is, and this is 2, this is 6y's. So we add them up the same way. We do, let's see, where do we want to start? X squareds. I only have one x squared. I have negative 2x squared. Then I have a minus 4x, and I also have a minus 5x. So I have minus 9x. Oh, this is x squared. Minus 9x. That's a minus sign there. By the way, I can tell who's actually doing this and who's actually not, like listening to it, because if you're not listening to it, you'll write everything down that I do, even if it's a mistake. Minus 9x, we have a 3xy, we have a 6y, and we have a negative 10 is equal to, and you guys do the length times the width. So the length is negative 2x plus 3y minus 5. And you guys just put that whole thing there. And the width is x plus 2. And you put that whole thing there. And I think you guys can finish that up. I think you can finish D up. And 48, make a rectangle from any numbers of squares. Then do the same exact thing that we've been doing. And you are good. All right, you guys, best of luck. Thank Mr. Adams, please, for letting you guys work in his room at this time. And I will talk to you guys later.